Good morning to all. Today our topic is an expansion device. It is located in between the condenser and evaporator. So this expansion device, it separates the high pressure side and low pressure side in the refrigeration system. This expansion device supplies the refrigerant according to the load on the evaporator. According to the load on the evaporators. So the main function of this expansion device, it reduces the high pressure, that is from condenser pressure to evaporator pressure by throttling process. Next function is it to meter and regulate rate of flow refrigerant from condenser to evaporator. That is mainly two functions. So these types of expansion devices are mainly two types: constant restrictive type expansion device, variable restrictive type expansion device. Constant restrictive type means there is flow of the refrigerant is constant, there is without considering the load. Without considering the load. It means the flow of the refrigerant is constant. There is no regulate the flow. So that is example is capillary tube. So capillary tube belongs to constant restrictive type. So the variable restrictive type expansion device. So in this system, it regulates the flow rate of flow according to the load conditions. According to the load condition, and it restricts the flow and regulate the flow and meter the flow. So in this type, examples are automatic expansion, thermostatic expansion valves, solenoid valves, high float valve and low float valve. Now I start with capillary tube. The capillary tube is mostly used in expansion device in small capacity vapor compression refrigeration system, that is up to 1 ton of refrigeration. So refrigerators, water coolers, room air conditioners. This capillary tube is reliable, the cost is low and simple construction. So but major advantage of this capillary tube is the refrigerant is free from the dust particles and moisture, because the condense capillary tube is length of the capillary tube is 1 to 6 meters and the diameter is 0.5 to 2 mm. Due to this low diameter, it coke the refrigerant. Coke the refrigerant. So to avoid this problem, to maintain the refrigerant free from the dust, free from the dust. So this capillary tube works mainly on the function of restrict the flow. Restrict the flow. Due to this restriction of the flow, the pressure is drops. The pressure is drops. The friction, due to the frictional resistance offered the flow, the pressure drops. So the the length of this the frictional drop is directly proportional to the length of the capillary tube and the inversely proportional to the diameter of the tube. Inversely, the frictional resistance offered by is directly proportional to length and inversely proportional to the diameter. So the length increases, the the pressure drop is increases. Length increases, pressure drop increases. The diameter decreases, the pressure drop also increases. So with that uh, principle, it works. This is the capillary tube. It is a coil type. It is generally we see on the refrigerator backside. The strainer, it's eliminate the dust particles in the refrigerant. So this is the entry of the refrigerant. Entry of the refrigerant. This is the capillary tube. Next, expansion valve. So the automatic expansion valve is belongs to the variable restrictive type expansion valve. So it controls the flow and quantity, regulates meters based on the load of the evaporator. Load. So it is generally used up to the 30 kilowatts capacity. So this automatic expansion device mainly works on the pressure, the spring pressure and evaporator pressure. So see here, this is the line diagram of this automatic expansion device. So this is also called as constant pressure expansion valve. Constant pressure expansion valve. It is a working on the constant pressure expansion valve. See here, PS is the spring tension and spring pressure, spring tension or spring pressure acting downward on the diaphragm, acting downwards on the diaphragm. P is the pressure in the evaporator acting upwards in the diaphragm. See here, spring pressure. The spring pressure acting downwards on the diaphragm. This is the diaphragm. This is the diaphragm. So P is the spring pressure, evaporator pressure acting upwards in the evaporator. Acting this, the P is acting upwards. PS is acting downwards. The PS is equal to PE. The diaphragm is neutral position. Neutral position at that time. This here, this is the push rod. This is the seat needle. Needle. So this needle, due to this needle, the PS is equal to PE. The pressure acting on the pressure PS is equal to pressure PE. So at that time it is in valve open position. The liquid refrigerant here to from bottom to top flows. This refrigerant liquid refrigerant goes to load side. So there is a load. This liquid refrigerant, it evaporates the continuation of the flow. So there is no evaporation, there is no load at that time. There is no load, there is no evaporation of the refrigerant. That time what happened? The PE pressure is greater than PS pressure. PE pressure is greater than PS pressure. PE pressure is greater than PA pressure. What happened? The PE pressure, more pressure from the downward compared to PS. The diaphragm moves upward. So the push rod moves upward. This opening is closes. The flow of refrigerant is stops. Flow of refrigerant is stops. So flow of refrigerant is stops. So until the equilibrium position, that is the PS equal to PE. PS equal to PE. So the refrigerant, it absorbs the heat and it evaporates. The pressure decreases. So that is PS equal to PE. Then the PS equal to PE, it is neutral position. The push rod moves downward direction. Then again the refrigerant moves from bottom to top, the refrigerant flows. So PS is greater than P, that time also the push rod moves downward. Push rod moves downward. The refrigerant flow is more compared to neutral position. The refrigerant flow is more compared to neutral position. So this is the this is the automatic expansion device or constant pressure expansion device.